In this video, we have the integral of 10 over sine of x plus cosine of x quantity squared. If you want to give this a try, go ahead and pause the video, and I'll be right back. Okay, I'm going to start over here, and since we have the denominator squared, we might as well start there and square the denominator. It'll be sine squared, and then it's double the product of sine and cosine. This will be 2 sine x cosine x, and then I've got cosine squared. So this is an equal to, in the denominator I've got sine squared of x plus cosine squared of x. That's one of your basic fundamental identities. That's equal to 1. So I've got a 1 plus, and then here I've got 2 sine x cosine x. That's one of your double angle identities. This is equal to sine of 2x. So I've got the 10 up here, and then your dx. Now I'm going to multiply by the conjugate here, looking ahead. Multiply by the conjugate of 1 plus sine 2x. And that's legal as long as I do the same thing to the numerator. So this would be 1 minus. Let me move this over to this side. So this is equal over here then. In the denominator, I'm going to have the sum and the difference multiplied here are the same two terms. So that gives me the difference of the squares. So this will be 1 minus sine squared of 2x. And I've still got the 10 up here. And this is multiplied by 1 minus sine of 2x. And then 1 minus sine squared of 2x. Using again your fundamental identity where you have the cosine squared of an angle plus the sine squared of the same angle equals to 1. So if I solve that for cosine squared, in this case it's going to be 2x, so this gives me cosine 1 minus sine squared of 2x. It's the same thing as cosine squared of 2x. And that's going to equal to, I'm going to put the 10 out in front here. And then I'm just going to divide through by cosine squared of 2x. So it'd be 1 over cosine squared of 2x. But cosine and secant are reciprocals. So this will just be secant squared 2x. And then I've got cosine squared over under the minus sine of 2x. So minus sine of 2x divided by cosine squared. I'm going to rewrite that on the side here. Minus sine of 2x. And I'm going to take 1 cosine here in the denominator of this expression. And then I'm going to isolate another one over here. 1 over cosine of 2x. Okay. So again, 1 over cosine squared 2x, that's secant squared 2x. And then minus sine of 2x over cosine squared of 2x. I broke up the cosine squared into 2 factors here. 1 under this one here. So that's going to give me a minus sine over cosine tangent of 2x. And then the other one is 1 over cosine, but that's secant of 2x. So 1 over cosine of 2x is the same thing as secant of 2x. So they're reciprocals. I put this in parentheses. You can look at this as one integral or 2 integrals, but I'm going to leave it as 1. Just integrate term by term. So I've got then this is going to equal to secant squared of 2x. The integral or antiderivative of that is tangent of 2x. And then using the chain rule backwards, derivative of 2x is 2, so this will be divided by 2 here. And then I've got a minus tangent secant. The integral of that is secant. The root of secant is tangent and secant. I'll put this as secant of 2x. And again, the root of 2x is 2. So this goes under here. And then you got, this is multiplied by 10. So let's just do it. 2 into 10 gives me 5. So this will be 5 tangent of 2x. And then 10 times the second term, secant 2x over 2. 2 into 10 is 5 again, and minus here. This will be minus 5. Secant of 2x plus the constant of integration. The final answer here. 5 tangent of 2x minus 5 secant of 2x plus your constant of integration. Thanks for watching. We'll see you next time.